Last but not least, we need to talk about graphing. How do we graph exponential and equations, exponential functions, as well as logarithmic functions? Well, it's interesting. If you think about it, if we think about a power, let's say power of 10, 10 raised to the 0 power, what does that equal? That equals 1, right? So if 10 to the x and x is 0, we end up with 1. So 0, 1 right here for an exponential function is always going to be a point on the curve. Why? Because it doesn't matter what our base is, 9 to the x. 9 to the x, if x is 0, if x equals 0, 9 to the 0 equals 1. 25 to the 0 equals 1. It doesn't matter what you raise to the 0 power, it's always going to equal 1. So every exponential graph is going to go through the point 0, 1. It's just that depending on how big the base is, depends on how steep it is. You notice here that this 10x curve, 10 to the x, moves up much quicker than this e to the x. And the reason is, again, e, the value of e is 2.718. So you can see where does it cross? So you see 10 to the 1 is right here. And then e to the first power is right here. It's right along this, right there. And that value should be 2.718. Okay, now on the opposite side of it, since these are inverse functions with logarithms, our log of base 10 is here, okay? And excuse me, that's our ln. That's our log of base 10 is this one. It grows more slowly, but all of them cross this point of 1, 0, 1, 0. Because it's an inverse function with the exponential functions, you just switch the x and y values and you have a point that's always going to be on the graph. Now, what's really interesting is if we were to take this function up here, y equals 10x, and say let's say we add 5 to it. What that's going to do is it's going to take, actually, I don't want to use that one. I'm sorry. Let me do a different one. Let me do this one. If we take the y equals log x and instead say add 5 to it, what that's going to do, it's going to take this log function, this guy right here, this guy right here, and it's going to shift it up 5 spaces. 1, 2, 3, 4, 5. It's going to shift it up to here. So it's going to end up looking like this. It's going to end up going like this. And when it does that, you're going to see that it intersects this at 2 points. So what I'm going to do is let me show you that a little bit cleaner, because this is something you're going to have to know for your quiz. If we have a graph of a log function and an exponential function, but one of them's been shifted, you've got this function going like this, using the x-axis as an asymptote, which means it never touches it. It just comes close to it. And then you've got the other one going through here, so it's coming like this. Okay? If we shift this one, the bottom one, you're going to end up with it going. If we shift the bottom one up, we create a graph like this where it has 2 points of solution. So this graph is a log x plus something, probably 5 or 9 or something. And then this one right here is your exponential graph. This is 10 to the x. Okay?